All right, this is the solving a binomial by using difference of squares. Okay, so we have to make sure our quadratic's equal to 0. If not, move all terms to one side. We always do that. We always try to take a GCF out to make sure it's smaller to work with. The reason that this one is going to be solved differently is because each of the terms is a perfect square, and they are being subtracted from each other. So this won't require us to do a times c or make a box. All we have to do here is take the square root of each term and then write that as a product where one of them is plus and one of them is minus. Once we have it factored, we set them equal to 0 and solve. So as I look at 4x squared minus 1, all the terms are on one side, equal to 0. I can't divide a GCF out of each term, so I'm ready to take the square root. The square root of 4x squared and the square root of 1. If they give me perfect square values, then I can do the difference of squares. The square root of 4x squared is 2x. The square root of 1 is 1. So I can write this as a 2x plus 1 and a 2x minus 1. Because they're set equal to 0, I take each of them and solve. This will give me x equals negative 1/2, and the other factor gives me x equals positive 1/2. The difference of squares only works when it's a binomial, so only two terms. It only works if they're both perfect squares. It only works if you are subtracting. So I'm going to move my 9 to get all my terms on one side. I'm going to realize that I can divide each of these by 9. So I'm going to divide the 9 out as a GCF. Looking at the previous problem, I know that the square root of 4x squared and the square root of 1 are perfect squares. So when I write this in factored form, I can't forget about the 9. The 9 is part of my factor. However, if I'm solving for x, there is no x here. So I'm only going to solve by setting the factors with x equal to 0. So even though this problem looked different to start with, when I solve, they will have the same answers. Final example. I have a binomial. Everything's on one side. There is nothing I can divide out, so there's no GCF. Like on this one, I could divide a 9 out. I know that the square root of 121 and the square root of 25x squared are perfect squares. The square root of 121 is 11, and the square of 25, the square root of 25x squared is 5x. So I'm going to put these into 1 plus and 1 minus. However, the x squared was the second term. So I have to write this as 11 plus 5x and 11 minus 5x. Order matters in subtraction. So I always take the square root of the first term, and that goes in the grouping symbol first. When I set these equal to 0, because they both have an x, I will get a negative 11/5, or I will get a positive 11/5. And those are my answers.